Class example 3.2.3. Match each graph with a situation from the list below. Explain your choice. Suggest titles for each axis to show the quantities being compared. So we've got graph A, looks like it's a nice smooth curve. Graph B, it's heading up and then plateaus. Graph C is heading in a downward direction, nice smooth curve. Graph D is a straight line heading in upward direction. Okay, I also notice they all start at 0, 0, so that's good. Okay, the temperature of a cup of hot chocolate over time. Okay, so temperature of a cup of hot chocolate. Hot chocolate's going to start out pretty warm, and as time goes along, it gets colder and colder and colder and colder and colder. So it goes from hot to warm to cold. So in other words, the temperature is going to be decreasing while the time increases. So this time is going to be our x variable because it's our input. We don't get to manipulate time. What happens here, what we're looking for is we're looking at for what is happening to the temperature. So our temperature is going to be our y value. Okay. So we are looking for time increasing while temperature is decreasing. In other words, while x is increasing, y is decreasing. I say that that's going to be graph C. Okay. So we can say that this is going to be time. So if I started at 0 minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes, after 10 minutes, I'm going to have a pretty cold cup of hot chocolate. So our temperature is going to go along that y-axis. So this would be A. Question B, a car accelerating to a constant rate. Okay, so it's a car, it's accelerating, and then it becomes constant. So we are talking about the speed of a car. And we could talk about this over time, or we could talk about this over distance. Okay, so as the distance is increasing, our speed is going to increase and then steady it itself out. Okay, so in this particular case, I think that we're talking about a car accelerating, and then we're going to be at a constant speed. So we should say that graph B, my speed is increasing and then my speed is staying the same. Okay. Question C, the distance a person walks during a hike. Well, that one's could be either. So if this hike is circular or if it's just going to keep going, we're not sure. Next, the height of a soccer ball kicked across a field. Okay, so this one here, the height of a soccer ball is not just going to magically stop. Now, if we're talking about the distance a person walks during a hike, this distance could just be within the first, 15 minutes of a walk, they have gone, a certain amount of distance here. So we could say that at any one point they could increase their speed, they could sit down and have a break, they could end their hike, who knows what it is. But a soccer ball doesn't just stop in midair. So a soccer ball, when it is kicked across an entire field, is going to start at the bottom. It's going to rise up to a maximum height, and then it's going to start to decrease its height and hit back onto the field. So this would be the height. And this is talking about the distance across the field. So this one is going to be D, which means our hiker is going to be in C, and it says the distance a person walks during a hike. So during is an indication of time. So as time goes on, how far did they walk?